When dealing with confidence intervals, the sample size is important, that you have the right number, or at least the right number, to get a certain degree of accuracy. So we have formulas that help us figure what that number is. And it says when an estimate of p hat is known, then this is the formula. And that's the z alpha over 2 that we just found, and you square it. And then you would have your p hat and your q hat. What is q hat? Q hat is 1 minus p hat. So if p is 0.8, q is 0.2. E is your margin of error, and that is squared. And it says when no estimate of p is known, you use 0.25. And what that comes from is that you let p be 0.5, and then q is 1 minus 0.5, which is 0.5, and 0.5 times 0.5 is 0.25. So if you don't really know a previous estimate for p hat, you just use 0.5, which turns this p times q hat into 0.25. Okay, this is the problem that we are trying to come up with the answer here. Now, this margin of error can be tricky too. In the study, they estimate the percentage of full-time college students who earn bachelor's degrees in 4 years or less. Find the sample size needed to estimate the percentage. A 0.05 margin of error. So the width would be 0.1. It's twice the margin of error. Width's going to come into play when we get to StatCrunch. Use a confidence level of 90% and complete parts A through C below. So we go to Stat. We want to go to Proportion Stats. We do have just one sample, but we want to go to Power or Sample Size here. Your alpha, what is your alpha? If it's 90%, your alpha, we want confidence interval with width. That's what you want. Your confidence level here is 90. Your target proportion, you don't have one, so we will just let that stay at 0.5 and a 0.05 margin of error. But if you double 0.05, what do you get? You get 0.1. So the width should be 0.1. All right, my sample size should be 271. Okay, it said assume prior studies have shown that 45% of full-time students earn bachelor's degrees. So the target proportion, which was, this is basically the p hat there, is 0.45. And you would need 269. Does adding the knowledge in Part B have much effect on the sample size? Well, you're comparing 271 and 269. That's not much difference. That's not but 2 people. So no, using the additional survey information does not change this sample size, or no, using the additional survey only slightly reduces it. It slightly reduces it, but not much. If p hat had been much greater than 0.45, it would have made a bigger difference.